This is the second part of the fourth soils unit on soil organisms. Let's consider the protista. The protista in soils include fungus-like organisms, the water molds that are important disease-causing organisms, algae, protozoa, and slime molds. Algae are present at the soil surface where they carry on photosynthesis because they have green pigment, chlorophyll, like normal plants, although their contribution to the productivity of the ecosystem is much less than that of plants. The protozoa include organisms like amoeba that crawl around in the moisture film on soil particles, feeding on soil bacteria. The slime molds have a similar lifestyle, but they are more noticeable when they come together in a mass at the soil surface. In some residential settings, a growth called dog vomit fungus, appropriately so, can be seen on mulch. This is not a fungus, but a slime mold that arises when the mulch has not been fully composted. Okay, let's talk about animals a little bit. Several animals live in the soil, from very tiny nematodes to burrowing rodents and serpents. The three most important types of animals are nematodes, larvae, and earthworms. Nematodes are small, worm-like organisms that feed on plant roots, fungi, bacteria, and other nematodes. Those that feed on roots can be a problem in crops, both in the field and in pots. Others that feed on fungi and other nematodes can be beneficial if what they feed on attacks plants. Here is an example of beneficial nematodes that are sold for control of grubs. Another animal are the insects. Now, larvae are the immature form of insects commonly found in soils. These are insects that have a complete metamorphosis. Depending on what insect the larvae is, determines if it is a pest or not. Some larvae and their adult form do not do any damage to plants. For other insects, the larvae is the stage that is most damaging because they feed on plant roots. There are some where the larva form is not a problem, but the adult will feed on plants when it emerges from the ground. Among the most pernicious larvae who feed on turfgrass roots and adults who feed on many trees and shrubs are the Japanese beetles. Now, there have been quite a few studies on the Japanese beetle and its control because it is such an important pest of turf and ornamental plants. Another very important animals are the earthworms. They have a special place in the soil ecosystem because of their effect on the soil. Along with creating macropores for drainage with their burrowing, they improve soil by creating aggregates when they excrete the soil they ingested while feeding on organic material. These aggregates are called casts. Most of the U.S. soils are colonized by earthworms introduced from Europe, and many view these exotic organisms as an example of a benign and maybe even beneficial introduction of an exotic species. However, there are some who view earthworms in a less than positive light because they alter the soil ecosystem in northern, for example Minnesota, forests, where earthworms were not naturally part of the soil environment as they were wiped out by glaciers. Nevertheless, in typical agricultural and urban soils, earthworms are considered extremely beneficial. Now finally, let's consider plants themselves as soil organisms. As with above-ground terrestrial ecosystems, plants are the base of the food chain below ground. Photosynthesis sugars and other carbohydrates are present in plant roots and provide sustenance for heterotrophs either directly or indirectly. As you know, roots serve three functions: support for the plant, permit the water and nutrient absorption, and act as a reservoir for food. The carbohydrates stored in the roots can be moved back up into the above ground parts when needed. Active root growth is critical for root function. If it isn't growing, it isn't taking up water and nutrients. The main parts of the root are the root itself, root hairs, and the root tip and cap. The root hairs are the part of the root that does the actual extraction of water and nutrients from the soil. The root tip explores, so to speak, the soil for areas to penetrate to give the root hairs access to water and nutrients. Roots and root parts are constantly dying, with new roots regenerating. As the old roots decay, they release organic materials and create channels that are very important parts of soil characteristics. Very often, more than half of a plant's root system will be replaced by new roots annually. This graph shows that about 60% or so of the fine root systems of trees in temperate forests, seen with the orange bar and the yellow arrow, are essentially replaced on a yearly basis, indicating that half of the fine roots have decayed and been incorporated into the soil system of that site. The proportion is even higher for the fine roots of tropical trees. So, like the other organisms, plants contribute to the formation of their own soil environment. The ecological succession of plants is the result of the soil types formed by preceding species. Clearly, soil ecosystems are complex. They are not completely understood, and they are also very dependent on the organisms living and dying in them. Without this biological activity, soil would be mostly structureless and infertile. Unconsciously, the soil organisms build an environment that supports plant life and us. So make sure to thank an earthworm today, and don't forget to thank those bacteria, fungi, nematodes, and plants in the soil as well. Here are some review questions that you may want to consider as you look over this material. What are saprophytes and how do they affect soil formation? What is the symbiotic relationship between nitrogen-fixing bacteria and many plants in the Fabaceae family? What are the roles of bacteria in the nitrogen cycle? Why is it sometimes necessary to add nitrogen when using organic mulch? What roles do earthworms play in soil formation and structure? And what role do roots play in the life of a plant? And why is active growth necessary for roots to function?